Hello there. So far, we have tried out examples applying the first special trig limit, the limit of sine x over x as x approaches 0 is equal to 1. So if you want a proof of this one, you may check out a previous video regarding this limit. Now for this video, we'll be trying out examples using the second special trig limit, the limit of 1 minus cosine x all over x as x approaches 0 is equal to 0. So this is what we'll be working on in this video. If you want a proof of this limit out here on how we arrived with this one, you may check out a previous video as well on proving this limit out here. So without further ado, let's go on to our examples. So in here, before we even start, first that it is easily verifiable that if we plug in these values out here, then the function out here would be an indeterminate. So you can do that one on your own. And yeah. And before we solve these examples, feel free to pause the video so that you may try these first on your own. Okay, good. So to start, let's go on to our first example. We have here the limit of 1 minus cosine 5x all over x as x approaches 0. How do we solve this? We apply a trick similar to what we did in the examples on the first special trig limit. We observe the cosine out here. Observe that x has a constant beside it, which is 5. Given this, before we can apply the special trig limit, we can multiply 5 over 5 out here. We can do this since 5 over 5 is just equal to 1, the identity. That means the expression out here won't change its value. So multiplying 5 over 5 will obtain 5 times the limit of 1 minus cosine 5x all over 5x as x approaches 0. So the 5 in the numerator moved out of the limit. We can do that by the algebraic property of limit. And then for the denominator, we moved it and we combined it with the denominator x originally. Given this, observe that the limit out here is already similar to our special trig limit. Indeed, if we let y in this case, variable y, to be equal to 5x, then observe that as x approaches 0, what happens to y? Well, take note first that we have x approaching 0 out here since we have this. So as x approaches 0, y out here, if this approaches 0, then obviously y will also approach 0. This means that we can express the limit out here as the limit of 1 minus cosine y all over y as y approaches 0. And we know that by special trig limit, this out here approaches 0. So we have 5 times 0 out here, or simply just 0. This out here is the final answer for this first example. I hope you got that one correctly, and let's now move on to the second example. In here we have the limit as x approaches infinity of x times 1 minus cosine 1 over x. How do we solve this? Take note that this function out here we can actually write this as 1 minus cosine 1 over x all over 1 minus x. So this is just by property of fractions. So technically, the x out here moves in the denominator as 1 over x. And now observe that this here is quite similar to our special trig limit. Indeed, if we let, say, z to be equal to 1 over x, then observe that as x goes to infinity, this one, what happens to z? Well, z equals 1 over x will approach, as x approaches infinity, we'll have here 1 over infinity. And we know that constant over infinity approaches 0. So z approaches 0. This means that we can express this limit out here as the limit as z approaches 0 of 1 minus cosine z all over z. Now from here, this is already the same as our special trig limit. It's just that our variable in this case is z. So we know that this approaches 0 as well out there. And so given that, we have here 0. And yeah, there's nothing we can really do about this. So we conclude that this out here is the final answer for this second example. So I hope that you got that one correctly and the solution was understandable. Now, let's move on to our third and final example. We have here the limit of 3 minus 3 cosine of x minus 1 all over x minus 1 as x approaches 1. How do we start with this one? We start by observing that in the numerator, we have a common factor of 3 in both terms. This means that we can factor that one out, just like that. And observe that this limit out here is already similar to our special trig limit. Indeed, if we let, say, w this time to be equal to x minus 1, then take note that as x goes to 1 out here, what happens to w? Well, as x goes to 1, so if we have 1 out here, 1 minus 1, which is equal to 0. This means that as x goes to 1, w goes to 0, which is what we want. Since we can now express this limit out here as the limit of 1 minus cosine w all over w as w approaches 0. Take note that I forgot to put the 3 out here. There should be a 3 out here. So just take note of that one. But either way, the answer wouldn't change since this limit out here is the same as our special trig limit. And we know that this approaches 0. So even if we have 3 out here, 3 times 0 would just be equal to 0. And so we have found the answer for this problem as 0 is the final answer for this third example. So that is the answer for this third one. I hope you got that one correctly. And these are our examples applying the second special trig limit. I hope that I was able to explain these examples properly and I didn't go too fast in each. So you may comment down below if you think that the way that I presented these examples are quite fast and complicated. So I'll check on that one. So yeah, you may take a screenshot of this one for your reference. To end this, here is a challenge for you to try on. So in this challenge, our goal is to find the limit of 1 minus cosine x all over x squared as x approaches 0. It's quite tempting to assume that this also approaches 0 since this is quite similar to our special trig limit. But take note that as a hint to answer this challenge, we have 3 hints out here. First, take note that the answer isn't 0. So take note of that one. And second, how do we solve this? Well, you can use the second special trig limit to show that this one out here is equal to 0 times infinity, which is an indeterminate. Or actually, you can just simply plug in 0 out here and you'll see that we'll have an indeterminate as well. I just wanted to emphasize that applying the second special trig limit out here wouldn't work. And third, what we can do instead, since the special trig limit didn't work, is we can try to multiply the numerator and denominator by 1 plus cosine x. So upon doing that, you'll see that something would happen and you'll actually be able to apply not this special trig limit, but the first special trig limit. So yeah, you may comment down below if you have a solution and answer to this one, or if you're stuck, you may comment it as well down below and I'll try my best to explain what and how you could modify your solution to arrive with the right answer. So yeah, although this example doesn't really apply our special trig limit, it's nice to check on since this looks similar to our special trig limit. You just remove the square out. So that's it. I hope you enjoyed and learned a lot from this video. Feel free to comment down below as well if you have any comments, suggestions, recommendations for this video, this playlist, or this channel in general. So yeah, that's it and that's all for this video.